Hi, everyone. Welcome back to this session on the startup pitches for the JEC Summit on Sports and Health. Next slide. There you go. So my name is Max Stewart. I'm the Sales and Business Development Manager for Industrial Products at Hexcel, and I'll be the moderator for this session today. We apologize for a little late. We had a little technical difficulty with my login. So without further ado, I'll introduce Dimitrios Pantasis. Dimitrios is the CEO of Alchemy. Alchemy is the worldwide leader in the manufacturing and distribution of state-of-the-art freediving and spearfishing equipment. The constant investment in innovation, the unceasing patent research in the field of manufacturing new materials and processes, combined with its expertise on composites and a creative professional approach, grants Alchemy its leading position and makes the brand a synonym of quality, safety, and reliability.
Thank you, Max. Hello, everyone. Can you hear me? Yes. Hello, everyone. This is Dimitris Pantasis, founder and owner of Alchemy in Athens, Greece. Alchemy is an underwater sports equipment manufacturer that produces mainly carbon fiber blades and fins for freediving, spearfishing, and underwater sports. The idea of professional equipment manufacturing started back in 2007, and it was driven by passion and love for constructions and the ocean. After my studies in physics department of Patras University, where I first met composites, and after 2 or 3 years of mostly home-based testing, I was finally in position to officially launch the company in 2010. Although fins made of composite materials was not a new idea back at the time, I had thought of some key elements which would advance such products in terms of performance, safety, and looks. When Alchemy started as a business, pretty much all competitors' products were manufactured by wet layup and press molding. And as a matter of fact, up until today, most of them still use the same procedure. We had also tried this process during our initial tests, but identified several flaws and points that made the final product really difficult to be monitored and the way we wanted to, in order to have a top quality result. This led us into taking advantage of the vacuum infusion process, which we are still using today to produce our blades and fins. That was quite new and difficult at that time because of the high cost of the consumables needed for the infusion process, but we knew that this was the first step to control our fiber to epoxy ratio and have a consistent result. That was our first innovation compared to other manufacturers' way of production, and even if it was not cost effective back then. Things changed over time as we invested into a state-of-the-art laser projection system for the dry fabrics layup, and our production capacity has been multiplied several times since then. Furthermore, what was really difficult to achieve, and we're really proud of, is the carbon fiber allocation within the blades themselves. What is needed when it comes to blades and fins for performance diving is a blade that will be gradually getting thinner and more flexible across its length. Unlike aerospace and motorsports, we're not only after lightweight and stiff parts, but instead we're looking for bending and flexural strength, feedback forces, and fatigue resistance of the part under a lot of stress in underwater conditions. We address this by using unidirectional carbon fiber fabrics in a V-shape, an industry first in the diving business, which also helped us get rid of the torsional flexion of the parts that resulted in a great loss of power. Thus, the longitudinal flex was enhanced and power loss was minimized, resulting in a great working fin that has taken athletes of our team down to 110 meters below water on a single breath, and back to the surface, of course. We also designed our own profile for the water rails, which are the silicone parts on the side of the blades that help the fins being steady by channeling the water that moves against them. Using an innovative C-shape, those rails have the ability to expand under a strong kick where more water is needed to be channeled onto the blade in order to perform a faster move. Looking forward, as we're constantly trying to experiment with new materials that will bring our products in the forefront of our industry, we are in process of testing carbon fiber nano-enabled materials for their enhanced tailor-made properties and getting our mold designs into a three-dimensional level. As the demand grows bigger, we also consider our options to transit from vacuum infusion into prepregs. But we're still in research in order to keep our standards and the final product intact during this transition. Finally, we are really excited about smart composites, and we are monitoring all the innovative raw materials presented globally because we strongly believe that composites that will change their properties according to their conditions they are into is probably a key element of the future top-of-the-line products. During this process, we also had the opportunity and luck to work with another Greek company called Adamant Composites in a European Space Agency technology transfer project. This project, made for sports, was about using materials developed for space applications into down-to-earth products. It resulted in some great prototype blades for fins with enhanced strength and impact resistance, which were also exhibited at JEC World 2018 Make It Real Planet, and featured on the official European Space Agency International website as a story at the Enabling and Support section. This project opened up the door of tailor-made nano-enabled prepregs that we are looking to incorporate to our products in the future by adjusting them for even better properties. After 10 years of presence and evolution in the market of diving equipment and several thousands of pairs of fins sold worldwide, we are happy to be a leading figure in our domain. Of course, on this road, we haven't been alone, as we are lucky to have a very talented professionals on our team. Awarded freedivers, designers, marketeers, creators, and technicians. Needless to say that the Alchemy freediving team has the largest number of sponsored competitive freedivers, an asset which, besides promotion, gives us extremely educated feedback on our products throughout the whole production journey from conception to completion. So, what does the future hold? The developments in the smart composite fields are coming along in high speed, and they are exciting. So, I'll guess we'll have to wait and see. So that was a little bit fast. I think we're okay.
Okay. Thank you very much. Our next sorry. So we'll do a 2-minute Q&A right now. We've had some questions here. So what are the parameters that are very important in making a good fin?
Well, first of all, it has to, the final part has to have a minimum air void. Air void, I mean bubbles within the matrix. In order to achieve this, I think the process we are using, vacuum infusion, is ideal because we have minimized the air traps inside the parts. And of course, the most important thing after that is the allocation of the carbon fiber across its length, because it affects the profile of the blade that bends against the water. So the way the inner layers are placed is critical to the final fin.
Very good. What's the advantage of carbon fiber in your specific application over other materials?
Well, the most common materials used, the cheapest one is plastic or rubber, and then is glass fiber that some people make blades out of them. The key element of carbon fiber, the thing that makes carbon fiber fins the best, is the energy transfer back to the diver. I mean, the energy the diver puts on their feet in order to move the blade against the water comes back as the blade oscillates back to its natural position, so it gives an extra push. Overall, this means less energy loss to the diver, which is critical for a great performance dive, for a deep dive.
I assume the fins are very thin. How do you manage to protect the diver from the kind of the shear edge of a carbon fiber blade?
Well, actually, this problem is minimized by the nature of the fins themselves. I mean, the side parts are covered with the water rails, which are made of silicone, and there is a foot-shaped, we call it foot pocket. You can imagine a shoe, which is glued onto the base of the blade. So practically, the only open edge of the fin is the tip. This tip is sealed, like it's very, very thin. It's like 0.6 millimeter, and it's sealed by using just a little bit of epoxy after the trimming.
Understood. I think this is time, so I would again invite you to go. There were a few more questions towards the end, so if you can go into the questions tab and perhaps answer some of the additional ones.
Okay, we'll do it. Can I do it? Can I do this off stage?
Yes,
sure,
you can. Absolutely. Thank you, Dimitrios.
Okay.
It's very nice to have you today.
Thank you very much. Thank you.
So let's move on to our second startup of the day, ProsFit from Bulgaria, a startup building accessible, affordable, and comfortable prosthetics. ProsFit has developed and commercialized a proprietary end-to-end digital solution to provide accessible, affordable, and comfortable prosthetics to millions of people who would otherwise find mobility extremely challenging. ProsFit sockets are manufactured with additive manufacturing. So I'm pleased to welcome online Krasimir Nikolov. He's an engineer and engineering and supply chain at ProsFit. An engineer with a passion for research and bringing new technologies where they're needed, Krasimir has been the core member of the ProsFit Technologies team since 2015. As an engineering and supply chain manager, and through his work on a doctorate at the Technical University of Sofia, he is addressing the application of additive manufacturing to additive manufacturing to prosthetic products. Krasimir is determined to develop and apply the right technologies to solve the ever-increasing needs and challenges in the prosthetics and orthotics industry, and implement ProsFit's vision of a world where innovation provides limb wearers a choice of affordable, reliable, and desirable prosthetic products and services. Krasimir, the stage is yours.
Thank you, Max. Hello, everyone. Today, I will present ProsFit, how we came to be, why we came to be, and what we're trying to achieve. So the harsh reality of the prosthetic world is that those highly skilled professionals, the prosthetists, are spending most of their time in an environment such as the one you see in the picture, basically handcrafting devices rather than working with the patients that they've trained to help. As a result, most of the sockets provided to patients are reported as not comfortable. Not only that the professionals are well overburdened, the number of amputees is very quickly rising around the world. In the next 10 years, it's expected, the number of amputees is expected to double. And most of those people are actually in low and middle income countries where they have very limited access to prosthetic services. As a result of all that, only about a quarter of the amputees around the world have actual access to prosthetic devices. So the mission of PostFit is to change that to a far more favorable figure. So we have developed our solution. We started in 2014 with our first 3D printed socket. That one was already a definitive socket and probably the first in the world. And since then, today, we have a global scalable business model, which should help deliver devices to at least 20 million people around the world if we're successful. How do we do that? Basically, we have changed the craftsman process, the manual creation of the devices, to an industrial process. The procedure of creating a prosthetic socket involves data capture of the limb. We have replaced the traditional plaster casting of the limb with 3D scanning. This step is followed by rectification of this plaster copy manually. This is now replaced with digital design through CAD software. And then the prosthetic socket, which is created traditionally in a very similar manner to those swimming fins we saw. This is now done through additive manufacturing, through industrial machines, and it's highly scalable. As a result of moving to industrial processes, the outcomes are far more systematic. The data captured from the patient is fully digital. The process for designing the device is far more easier to control and measure outcomes. Those two combined come up with faster provision to the patients and bringing them back to social integration. The face of this solution are our sockets. Initially, they were just replicating the traditional socket design. They weren't anything super fancy. They were single thickness devices. But as they were industrially manufactured, we went through ISO certification for those devices. Traditionally, prosthetic sockets are, as they're custom-made, handcrafted pieces. They don't go under any regulation, but ours do. So we have control over the performance of the device. And today, we have moved a bit forward. In the middle, you see the result of our partnership with BASF, a player outside the prosthetic industry. We have applied their flexible materials to improve the comfort of the patient when using our devices. And on the right, we are bringing back carbon into the equation. This prosthetic socket is the product of a partnership with SGO Carbon. It is again a digital solution. There is no manual process involved. The carbon is applied only where it's needed, again, in an automated manner. So how is this process scalable? We have split it into a few parts. The clinical part is the face of the solution. This is where the patient is admitted, data is captured, and the device is designed by the professional, applying their medical know-how. As the solution is fully digital, the actual design of the device can be done remotely. The software is available on the cloud. So a single prosthetist could serve multiple patients in many locations. The second part of the equation is PostFit. We apply the quality control over the design. We make sure that our devices meet the performance claimed by us. And third are the service bureaus who actually manufacture the devices. They apply outstanding quality control, and deliver the device to the clinic so it can be fitted back to the patient. The trick here is that the manufacturing is a very high-level industrial process. Equipment is very expensive as such. We have centralized the manufacturing. We have partners across the world who have gone through an evaluation process by us. We are approving our manufacturers that they can meet the requirements of our devices. And as the manufacturing and the design are detached from the clinic, it is now fully modular and scalable. The highlight of this is the potential for a mobile clinic, where everything could be put in a van. This van could simply travel around locations where services aren't existing and help fit patients. So all of these components, the regulated device, the digital process, the mobile clinic, and the localized central manufacturing come up with a very easily scalable solution. All of this provides benefit to the whole industry. First, professionals have far better productivity. They are much more flexible with their resources. This results in quicker prosthetic provision to the patient. They receive their time to comfort is shorter. They receive their device faster. They spend less time and less visits in the clinic. So they have their time easier. And the benefits for the professionals, together with the benefits for the patients, together drastically reduce the costs involved in prosthetic provision. So the whole industry benefits. Thank you. And if you have any questions.
Thank you very much. So let's see. We have not yet received any direct questions, so I would invite everyone to type your questions in the right. So a quick question. I did not see the device that you used to capture the foot on site. Can that be any device? Can it be done with a very simple device, or does it take another type of very advanced type of scanner?
It's a very good question. Data capture is key in the process. We are using 3D scanners to capture the shape of the limb. We are scanner agnostic. Whatever is available to the clinic works for us, as long as it can produce a file. But even with the very cheap scanners, we are able to produce good fitting sockets.
Ah, very good.
So these are small handheld devices, ideally.
Any other questions from the public? There we go. Are you using an unreinforced polymer for the 3D printer, or using reinforced material, for example, continuous fiber, FDM?
So we went through a few technologies in our cycle. We started with FDM. We weren't very happy with the performance. Parts were easy to fail, or at least prone to failing. We're currently using HP's MJF technology, and the material is not reinforced with any fibers. The major drawback of continuous fibers is that they're still bound within a single layer, so the product of continuous fiber manufacturing is very similar to FDM. So devices are prone to layer separation and such failure, where with the uniform polymer, we have better control over the performance.
Understood. think we have time for one more. Eric Piaget said, what is the average time between scanning and supplying a finished product? So how many days?
So we are promoting 5 business day turnaround time. If the doctor can scan the patient, design the device, and send the order on one day, let's say on Monday, on Friday they can receive the device. That's the benefit of the localized manufacturing. And
Wow.
in those 5 days, the prosthetist doesn't need to work anymore on this patient. They have their whole week free to fit other patients instead of compared to the traditional method.
Yeah, absolutely. All right. Well, thank you so much for participating today. Very interesting technology and a great application of 3D printing.
Thank you.
So let's move on to the last startup of the day, which is MOI Composite. Freeform on-demand performance advanced composite object. Free of mode with design and time constraints, MOI Composite patented process innovation can be new shapes, sizes, and performance, cost effectively and on demand. I'm pleased to welcome online Gabriele Natale, CEO of MOI Composites. Gabriele Natale is a designer and engineer passionate about the manufacturing process. Gabriele has a multidisciplinary background. During his master's degree at Politecnico di Milano, where he graduated in 2014, he studied design, mechanical engineering, and materials engineering. Prior to founding MOI, Gabriele has been a researcher at Plus Lab, the first 3D printing lab of Politecnico di Milano University, in which he worked on additive manufacturing, machine development, and materials testing. During his professional career, he worked as an industrial engineer for international projects, being involved in all the different phases from concept to engineering and prototyping. Gabriele, the stage is yours.
Hi, thank you, Max. I will share my screen. Okay, are you able to see my screen?
Okay.
Okay, nice. So thank you, first of all, to the JEC organization for giving us the possibility to present our startup on this stage. I'm Gabriele Natale. I'm the co-founder of MOI Composites. MOI is an early stage startup born as a spin-off of University Politecnico di Milano in Italy that works on a digital transformation of composite material. We want to change the way 3D printing, people think about 3D printing. We want to switch it from rapid prototyping system to a production method for real employable composite parts. We started to develop our technology considering that today traditional manufacturing requires mold that most of the time are expensive tools and limits achievable geometries. So in order to create a composite parts, today there's a lot of operation that need to be done manually. First of all, you need to create a model by which you can obtain the mold. So you laminate the mold, and then the mold needs to be, let's say, finished or prepared before you are ready to laminate the fiber. So then you need to use, after the lamination, you need to use the autoclave, wait for the completed resin curing cycle, and then after that, the part needs to be released and maybe eventually finished or trimmed. And for some particular components, the trimming operation can generate also up to 45% of waste of composite material. So in order to lead the time and shrink it, we developed a new technology called CFM, that is the acronym of continuous fiber manufacturing, that it's let's say, an hybrid technology between an additive manufacturing system and a fiber placement machine. So we started from a three-dimensional file, so a standard CAD file. We process it inside a software using our own algorithms and send it to a robotic arm that is able to deposit continuous fiber composite impregnated with thermosetting resin. So basically, we print like unidirectional pre-impregnated fiber. So our startup started in a couple of years ago. Basically, we started after winning the 2017 JEC award as researcher inside the university. And then in early 2018, we decided to develop our own company. So we developed MOI in order to deliver, to further expand the industrialization of our technology and deliver the potential of our solution to composite market. So going in depth, so as you can easily understand, the technology can be used in a really wide range of application for composites, starting from automotive, going to aerospace. We work it also for oil and gas, or even in building or in biomedical. As any 3D printing system, our patent process doesn't require molds. So we don't have like a break-even point on number of parts produced. And that is really a game-changing solution for small lots. As you can see here, I think we can play an important role in sport and health market, in which personalization is like a must to have, because especially on health, you need to create custom-made parts, as we saw before. In this case, for example, we print the food prosthesis in just 3 hours, and we realize it in fiberglass. This is our first material we can process with our technology. We started just analyzing the 3D model through a finite element analysis software, and we just inserted the real data of the final user, so the patient. So an intrinsic benefit of our technology is that we can optimize the fiber direction according to the stress. So we are also able to improve the performance weight ratio, let's say strategically placing the fiber along the maximum stress line. The truss you see in the video weighs just 80 grams. And we try to do it on a real case study. As for example, in the BMX bike frame, we did in collaboration with Autodesk. We started optimizing the fiber direction following just the tension and compression line of the bike frame. And that allowed us to create a really lightweight bike respect to the original frame by only putting the material when it was needed. And that is impossible to be manufacturing using traditional composite production system. And the last project for sport we did, and I would like to show you, is our, let's say, marine toys that is called Mambo. It's our last project we presented at the Genoa boat show 1 month ago, more or less. The boat is an inverted tricycle hull, 6.5 meter long, and it was created using a monoblock structure without the hull and deck division. Mambo demonstrated we can push the limits of achievable shape in composite even in large size, like a boat. So the boat was created using two robots that 3D printed the internal core of the structure in different sections, and then those pieces were joined and laminated inside a shipyard. So we also demonstrate that in some way we can merge the digital manufacturing technology, so robots can be merged with artisan works. And finally, as you can see here, we tested in the real environment. We tested in the sea many times, and right now we reached up to 26 knots. But we know we can go even faster, adjusting few settings on the engine. So that said, as a startup in seed stage, we are always looking to develop our connection. We are looking to develop new material, new application for CFM technology, and push more the limits of composite production. So we are always looking for, let's say, industrial partnership or inspiration of people who want to cooperate with us. Thank you.
Thank you very much, Natale. So we'll be taking questions. So please, everyone in the public, we've got 2 minutes. I would have one to start. So it seems your technology uses UV curing resin. Are there, and carbon fibers, of course, do not allow you the transparency to cure UV. Is there any development or future to be able to use carbon fiber on such a process?
Yeah, sure. Carbon fiber tend to absorb UV light. So actually, maybe we are able to cure like the external surface of carbon fiber, but not the inside. Right now, we are changing the curing system in order to be able to process also carbon fiber or other, let's say, non-transparent fiber. We are on the way to do that.
So in a sense, can the technology be used and combined with traditional composites? So can you, in other words, use that glass fiber as a mold for making a traditional composite?
Yes, this is exactly what we did for the Mambo project. We printed just the internal frame, the structure in fiberglass, and then all the pieces were joined and laminated. Then, of course, if you want, you can also create a mold. If you like the final result, basically from the first boat, you can create your mold as normally composite producer did. So you can obtain like in a really fast time first prototype, but it's not just a prototype. You can use it for real, and then eventually, if you want, you can create a mold from that.
Interesting. And we've got a great question from Natale. How do you deal with the resin that becomes less viscous at the beginning of curing? Is that well, first, is that a behavior of a UV cured resin? And second, how do you maintain the shape while this is occurring?
So actually, the curing system we are using is able to pass from liquid to solid in 20 milliseconds. So the fast curing time allowed us to create like even large object or really tall object, because the layer we already deposited still solid, still like fiberglass, already cured fiberglass layer. So we can put like the next on top of it and so on.
Very good. Well, I've been a terrible moderator. It seems we went significantly over time, but I want to thank everyone for showing up, and specifically our presenters today. That was very interesting. A lot of great questions. Again, you can go into the question section to fill the rest. I also want to thank our main sponsor, which is Supreme. And I'd like to invite everyone to come back for day 3, which is tomorrow, December 10th at 2:30 p.m. Central European time. And the business meetings will start at 4 p.m. And for the business meeting, and then at 4 p.m. will be the keynote and the industry sessions. So thank you, everyone, and have a wonderful rest of your evening or your day, wherever you may be on the world.